Welcome to another LFX tutorial. My name is Kings, and today we're going to be working on a menu topic. Okay, we're going to be working on physics and the topic kinematics. Alright, as you can see, when we click on new animation, you see these moving particles on the screen. If we pick one of this particle, okay, enlarge it, and kinematics, based on this particle, wants to know about the time of motion, the velocity of motion, the distance covered in its motion, and the acceleration of its motion. So kinematics tries to deal with motion of an object with respect to time, with respect to distance, with respect to velocity, and with respect to acceleration. Okay, what we're going to talk about now, we know about distance, everybody knows about distance, and everybody knows about time. So what we're going to talk about now is velocity and acceleration. So let's just bring velocity to this point and take off acceleration. Now, velocity of an object in motion is generally the change in displacement with respect to time. I'm going to divide velocity into 2 points. Okay, we have the average velocity and we have the instantaneous velocity. Right now, we're going to talk about the average velocity. Alright, so average velocity has 2 formulas. We're going to write it down. We have average velocity is denoted with V in a bracket. Average velocity is equal to change in displacement over change in time, which can also be written as the final displacement minus the initial displacement divided by the final time minus the initial time. Or we can write average velocity in this other formula. Average velocity, V, equals velocity, final velocity, plus initial velocity divided by 2. So this is the average of 2 velocities. For example, if an object is moving, let's just animate this, okay? Alright. Okay, clean up this. If this object is moving at this position, the object might have a velocity of 20 meters per second. And at this position, when the object moves to this position, the object might have a velocity of, let's just say, 10 meters per second. Now, if we are asked what is the velocity of this object, we know this velocity changes with time and we know it changes with position. So we simply find the average of these 2 velocities, like the final plus the initial divided by 2. 10 plus 20 divided by 2, which is 30, divided by 2, which is 15 meters per second. So this is one way in which we find average velocity. Now let's just take a sample question from with respect to average velocity. This question is going to be coming out from your past question. You can see it from the King's material. This King's material contains all the questions you need to know in photophysics and how they are being solved. So if we solve a little on this video, you can go on your own, get the material, or you can get it on Facebook website and actually in PDF format and go through the material. So menu question. Okay. Yeah, this question. Now this question says a rodent is moving along a straight line, a straight tunnel assumed to be in positive x-axis. At the time of 6 seconds, its position is 48.5 meters, and at a later time, t2, which is 8.5 seconds, its position is 73.5 meters. Calculate its average velocity. Alright, we have options given to you from this question. What we simply do is, we were given the final position, we were given initial position. Okay, let's just shift this question to this device. We're given initial position, we're given the final time, we're given initial time. So the final position is simply from the question. We have 73 meters, 0.5 meters. Initial position is 48.5 meters. Final time is let's say the final time is 8.5 seconds, and the initial time is 6.0 seconds. As we can see from the question, we can push the question away. Now, to find this average velocity, we simply say average velocity v equals 73, let's say x2 minus x1 divided by t2 minus t1. Now, which can also be written as 73.5 minus 48.5 divided by 8.5 minus 6.0. So if we punch this correctly in our calculator, we should have an average velocity of 10 meters per second. So this is one way in which we expect to see average velocity equation.